Hi everyone, and welcome to the video on the sum and difference identities. In these identities, what we're going to be looking at is when we take the sine, cosine, and tangent of a sum or difference of two angles. Okay, and the patterns that are associated with that. So, our skill objectives for this particular video are: 1, find the exact values of trig functions using the sum or difference identities, and number 2, develop new identities from the sum or difference identities. And we have one conceptual objective, and that's really to understand that the trigonomic function of a sum is not the same as the sum of the two trig functions. What this conceptual objective means really is that if I take, for example, the sine of something like 30 degrees plus 45 degrees, that is not equal to just the sine of 30 degrees plus the sine of 45 degrees. You can actually take this, put into your calculator and confirm that, but that is something that you have to realize that does not work. Now the basis of these sum and difference identities is from the distance formula, which you can see in this illustration. This is an illustration that is in your book. Okay, and with the distance formula we get to the sum and difference identities for cosine, and then through those and the co-function identities, we can get the sum and difference identities for sine. And when you put both of those together, we can get the sum and difference identities for tangent. Now, the proofs of these and the development of these are in your book in section 6.2, and we'll point those out during class. But I'm not going to go through the proof or the development of those right here. What we have, I have the first four for the sum and difference for cosine. The sum of cosine is cosine of a plus b, whatever a and b are, their angle measures, is going to be equal to the cosine of a times the cosine of b minus sine of a sine of b. And the cosine difference formula, by difference to a minus b. Cosine of a minus b equals cosine b plus sine a sine b. For the sine, we know that the sum formula for sine is going to be sine of a plus b equals sine of a cosine b plus cosine a sine b. And the difference formula, you get sine of a minus b equals sine of a cosine b minus cosine a sine b. Now these formulas are ones that you are going to, we're going to be using in this section quite a bit. We'll have to apply those and try to simplify expressions to try to go and answer questions with these. Let's take a look at an example here. In this case, I'm going to use the fact that 5 pi over 12 is what I would get if I take 3 pi over 4 minus pi over 3. Go ahead, pause the video right now to confirm that. Get your common denominator and then subtract them, and you'll see that it works out. Okay, welcome back. Now, what we have here now is going to be the, what we want to do is we want to find, use this fact to find the cosine of 5 pi over 12 and the sine of 5 pi over 12. Well, to do this, I know that the cosine of 5 pi over 12 by this information is going to be the cosine of 3 pi over 4 minus pi over 3. And now we have that cosine difference formula. We know that this is going to be the cosine of this cosine of 3 pi over 4 minus pi over 3 will be the cosine of 3 pi over 4 times the cosine of pi over 3 plus the sine of 3 pi over 4, sine of pi over 3. That is that cosine difference formula that you should have written in your notes now. So that's going to be the cosine of 3 pi over 4 times the cosine of pi over 3 plus the sine of 3 pi over 4 times the sine of pi over 3. Now these are angles that are on the unit circle, so we know what those are equal to. I know that the cosine of 3 pi over 4 happens to be negative square root 2 over 2, so that'll be negative square root 2 over 2, times the cosine of pi over 3, which is 1/2, plus the sine of 3 pi over 4 is square root 2 over 2, and the sine of pi over 3 is square root 3 over 2. And so when I do that, that's going to give me negative square root 2 over 4 plus, now the square root of 2 times the square root of 3. When I multiply those together, that will be the square root of 6 over 4. And so that we could also write that as square root 6 minus the square root 2 over 4. That would be one way to express that problem. Now let's take a look at the sine of 5 pi over 12. Well, in this case, I know that that is equal to the sine of 3 pi over 4 minus pi over 3. And again, by that sine difference formula, I know that's going to equal the sine of 3 pi over 4 times the cosine of pi over 3 minus the cosine of 3 pi over 4 times the sine of pi over 3. And so in this case, I know sine of 3 pi over 4 is square root 2 over 2. Cosine of pi over 3 is times 1/2 minus the cosine of 3 pi over 4 is negative square root 2 over 2. And the sine of pi over 3 is times the square root of 3 over 2. Now this right here can also be written in this way. I can see this one, and when I multiply it out and simplify it, I'm going to get the square root of 2 over 4 plus, now this time I'm not going to actually multiply those two out. It's just going to be plus square root 2 times the square root of 3 over 4. And so the other way of writing this one, an alternate way that you'll see, is I can pull out a common factor of square root 2 over 4. And so I can say that's equal to the square root of 2 over 4 times 1 plus the square root of 3. So that would be another way of writing that. I have seen books and authors use both. Sometimes I've seen them actually use both in the same problem set. So again, you just need to recognize, I want you to be able to recognize that something that each of these here, this one could have been, we could have done the exact same thing that we did here, pull out a common factor to write that one as square root 2 over 4 times the quantity of square root 3 minus 1. Or I could have this one distributed and simplified, and it could be in that form as well. So please recognize that these are very similar and that they can be, the expressions can be written in both ways. The next type of problem that you're going to see in this section is going to be really taking an expression and write this as a single trig expression. So in this case, you'll see two of them that I have here. Sometimes they're going to be very quick and very easy. It's just really identifying which formula it matches up. Others, like the second one, are really going to require some additional work. So in this first one, what we have is we want to write this as a single expression, and what we have right now is sine of 2x cosine 3x plus cosine 2x sine 3x. So what you want to do is look at those identities, the sum and difference formulas that we just have, that you have in your notes, and you want to go and check to see which one of those formulas matches up here. So the first thing I notice here is that I have sine and cosine, cosine and sine. So I have one in each, and I have an addition. And so with that, I know that that one is actually going to be the sum formula, because what I have for the sine sum is that the sine of A plus B is equal to sine of A cosine B plus cosine A sine B. So this one matches up that formula. So I know that when I look at this, I can say, well, the A is 2x and B is 3x. So I can say that this that we have up here is actually equal to just the sine of 2x plus 3x. So I get that this is the sine of 5x. And that would just be the answer on this one. In this next one, we have a little bit more work to do because this one right now doesn't match any of the ones that we have. So when I look at this one, the first thing I notice is I see that I have a binomial square. I'm having these two squares. So I'm going to have to multiply these out. Now, when I FOIL that, when I FOIL this, the first one, I'm going to get sine squared A plus 2 sine A sine B plus sine squared B plus. When I go and multiply out the second one, I'm going to get cosine squared A plus 2 cosine A cosine B plus cosine squared B cosine squared B, and then I still have that minus 2. So that's all multiplied out. Now what I'm going to do is I'm going to move things around a little bit. Everything's addition here, so that's nice. I don't have to worry about any negatives taking place. And what I'm going to do is I'm going to bring the squareds with A together. I'm going to bring the squareds with B together. I'm going to bring the other parts together as well. And so this is going to become sine squared A plus, cosine squared A plus, I'll do the 2 sine A sine B plus 2 cosine A cosine B plus the sine squared B plus cosine squared B minus 2. Now, what I have with that, when I look at this part right here, the sine squared A plus cosine squared A, that's one of our Pythagorean identities. So I know that is equal to 1. And I'll have this plus the 2, 2 sine A sine B plus 2 cosine A cosine B. And again, this part right there, sine squared B plus cosine squared B, that is 1. Then minus the 2. Well, at this point, the 1 that we have, this 1, and that minus 2, those are all going to end up canceling each other out. And so, when I look at this one, this is now what I have right here. I can pull out the 2, pull out a factor of 2, and I'll get sine of A, sine of B, plus cosine A, cosine B. Or if I want, because it's addition, I can change the order, make it look more familiar. That's going to equal 2 times the cosine of A, cosine of B, plus sine of A, sine of B. And that, when we look at this, that right there looks like the cosine difference formula. I know that in terms of cosine difference, that the cosine of A minus B equals cosine A cosine B plus sine A sine B. That's from the I formulas that we had earlier. So therefore, I know that this thing here is going to be equal, that I know that what's in the parentheses is going to be the cosine of A minus B. So this is just going to be 2 times the cosine of A minus B. At this point, take a couple minutes, pause the video, make sure you're comfortable with the calculations I did on this one as we went through, and when you are, we can move forward. Another type of problem you're going to have to do is they're going to ask you to go through and identify if an expression is a conditional equation or an identity. Now remember, conditional equation means that it's true for some values of x. Identity means it's going to be true for all values of x. So in other words, what we really have to do on these is we have to go through and we're going to take these expressions and we're going to go and see if they are actually the same. Okay, so what I'm going to do, I'll start out with that first one. The cosine of 2x equals cosine squared x minus sine squared x. So what I'm going to do for that particular problem, I'm going to actually kind of do a little manipulation. I know that the cosine, by the cosine sum, I know that the cosine of a plus b is cosine A, cosine B, minus sine A, sine B. So what I'm going to do on this one, I have the cosine of 2x. Well, I know there's a lot of different ways of coming up with 2x, and one way that I can do it, I can write that as cosine of x plus x. Now, x plus x is 2x, but now it's also written as a sum. So I can apply the cosine sum formula. And that cosine sum formula says that that is going to be the cosine of the first, which is x, times the cosine of the second, which is also x, minus the sine of the first, which is x, sine of the second, which is x. And when I simplify it, I get cosine squared x minus sine squared x. So in essence, I've been able to go using the cosine sum formula, I've been able to transform this, the cosine of 2x, into this. So therefore, in this case, this particular problem, this is an identity. On the second one here, I have the sine of x plus pi over 2 equals the cosine of x plus pi over 2. Well, what I'm going to do is I'm actually going to use the cosine and sine sum formulas to go and rewrite actually both sides here. So in this case, this is going to be, what's on the left, the sine of x plus pi over 2 by the sine sum formula is going to be sine of x cosine pi over 2 plus cosine x sine pi over 2. Now, with that, that is going to equal, on the other side, using the cosine sum formula, that is going to be the cosine of x cosine pi over 2 minus sine x sine pi over 2. Now at this point, what we have to do is identify, we have to use the unit circle, recognize that we know that the cosine of pi over 2 is going to be 0, and sine of pi over 2 is 1. And so this side, what's on the left, this first term, the first term is going to end up being just sine of x times 0 plus cosine of x times 1, and that's going to equal the cosine of x times 0 minus sine of x times 1. And so when I simplify that, what I come up with, on the left side, I'm just going to get cosine of x equals the opposite of the sine of x. Now in this case right here, when I simplify that, there's no way for me to go and make cosine into exactly the opposite of sine. It's not, there's no identity that does that. So in this case, for this particular problem, the second one, that is a conditional equation. As with the cosine and sine sum and difference formulas, the proofs for those are in the book. The same thing is true for the tangent sum and difference formulas, and so we can take a look at that in class, or you can take a look in your book right now if you want. But the tangent sum and difference identities are the following: the sum of a tangent, so tangent of a plus b, is tan a plus tan b over 1 minus tangent a tangent b. And the tangent difference formula is the tangent of a minus b is equal to tangent of a minus tangent of b over 1 plus tan a tan b. Notice in all these identities, notice what's happening with the SIG ends, the addition and subtraction signs that we have in the problem, and how they are related to what this written as a sum of angles, and then how it is with the formula, because that will come into play in terms of helping you kind of remember what these are as well. So now let's take a look at another couple examples here with these. What they're going to ask you to do is rewrite this expression in some way. Now in this first one, when I look at that, again, like we did in the last one, now we do have degrees, so I guess that's nice. But what we have is you need to recognize that this one is really just the tangent, the difference formula. And that what's in the A spot is 47 degrees, and what's in the B spot is 15. So this is really just the tangent of 47 degrees minus 15 degrees, which equals the tangent of 32 degrees. Now in the next one, what we have here, we want to write that as a single trig function in this case, okay? And so what we have on this one, we got a little issue in that we now have the square root of 3. But one thing I need to recall on this one is you need to remember that, the tangent of pi over 3 is equal to the square root of 3. That's from the unit circle. And so when I look at this, I can think of this one as the tangent of pi over 3 plus the tangent of x over 1 minus the tangent of pi over 3 times the tangent of x. And now looking at this one, this is in the form of the tangent sum formula. So that is just going to equal the tangent of a plus b. So a in this case is pi over 3 plus b is actually just x. And so that would be our answer on this particular problem. So this does conclude the video that I have for the sum and difference identities. So with that, I hope everything is going well, and that and we will see you in the next class.